Welcome back. Today's video, as part of our TASC math preparation, will be centered on inequalities. Once again, if you're one of my adult learners, the link at the top of the video is where you can register to access our virtual learning space. And in parentheses is the code that you'll be required to input to secure access to these materials. If you're not, welcome. And I wish you the best of luck along your own journey towards obtaining your general equivalency diploma or your high school equivalency state diploma. Here we go. So a mathematical sentence that uses an inequality symbol to compare the values of two expressions is known in the mathematics realm as an inequality. A little slight variation from an equation, right? Where in an equation we use an equal sign. In an inequality, we are going to see the use of these four symbols. Okay. And at first glance, they have a, it becomes almost like memorization. I have a little trick or tip, right? For the one that we see here, if I were to draw the letter L, okay, and if you took the top or the vertical aspect of that L and you bent it forward slightly, it would turn into the symbol that you see before you. So we have less than. And here we have the same symbol, except there's a little line underneath it, which designates or equal to. There is a huge difference between the two. In essence, the first symbol means, actually, let's define these two and then we'll talk about the nitty gritty. Right, so then we have greater than. Oops, that's not it. And then obviously same thought process here, greater than or equal to. It's just inside my parentheses. Okay. So like I said before, these are definitely some symbols that you're definitely going to want to commit to memory with. If we make an L, here's an L, right? It's backwards. Okay. And we slice this forward, right? We can see the similar symbol. And striking similarities to the English language, we'll come to see. We read things in English from left to right, and the same holds true for mathematical expressions. So if we were to construct inequalities that represent the following verbal expressions, because that is always the goal, right? Take what we're experiencing in our world and create some type of mathematical notation to model it. We have all real numbers x less than or equal to -7. So obviously we're going to start with our first piece, which is our variable. X less than or equal to, right? So less than or equal to. That's not coming out right. So naturally my pen does not want to function with me so early in the morning. That looks like a C now. One last try. Best one yet. Okay, -7. And this is crucial, right? Because it's only, less than or it's greater than, 50-50 shot. But you write the wrong symbol, but you're operating under the assumption that is correct. Anytime you come across an inequality problem on your TASC test, on your GED, on your high set, you're inevitably going to wind up getting it wrong since you're reading and misinterpreting the information being shared. Okay. 1B, slightly a little more complex. 6 less than a number k is greater than 13. So I'm actually going to pause on that first piece. All right, we'll delve into that in a second. Is 6 less than a number k? We'll just start with here. Is greater than, right? So greater than 13. Okay. 6 less than a number. Evidently, it's going to be subtraction. Now, the issue here, right, when we have subtraction is which piece goes first, okay? And why that becomes an issue is because in addition and multiplication, we have these mathematical properties that say no matter which way you add two numbers, no matter which way you multiply two numbers, you'll get the same value. Case in point, 2 times 4, 8. 4 times 2, 8. Not much has changed. Okay. However, with subtraction and division, the order in which you subtract or divide does matter. Case in point, 4 divided by 2, 2. 2 divided by 4, 1/2. So getting back to this, 6 less than a number k, I always tell my adults to make k a value, right? Imagine I have $20 and you have 6 less than me. Okay. You would have, I guess you can use math here, or maybe common sense. 6 less than 20, 14. Well, how did we calculate that? We took the value of 20, we subtracted 6 from it, right? So we took 20, which is really our k, and we subtracted 6 from that. And obviously the rest is greater than 13, okay? The blank of an inequality is any number that makes the inequality true or false. The solution is any number that makes the inequality true. Okay. And like I said to begin the video, not much is changing here between inequalities and equations. There's one subtle nuance, but for the most part, it's relatively consistent. Okay. So in this instance, for checkpoint 2 and 3, I'm only going to do 2 and leave 3 for you. But are the following numbers a solution of 2x plus 1 is greater than -3? We would simply take whatever value we've been giving, in this first instance, -3, and we would substitute it in for, and you are not working with me today, pen. In for, that's better. In for x, right? So 2x, bad habit. 2 times x, much better habit. So we have 2 times -3 plus 1. Remember, being able to read these symbols is the most critical piece, right? So that symbol would say is greater than. So let's verify. -6 plus 1. It's really, you're going on timeout after this video, equals -5. And is -5 greater than -3? No. So not a solution. Okay. And if you're sitting there wondering why -5 is not greater than -3, this goes back to the number line, and conveniently enough, we have 1 below. You can see the more we go to the left on the number line, the smaller the number becomes. Okay, so unlike the positive values, right, where as the numerical value increases 5, 6, 7, 8, 9, 10, right, with the negatives, as that numerical value increases, it technically means less. I mean, also think about, would you rather owe $5 or $3? I'd rather owe 3, so 3 is going to be greater than -5. Okay, and we would replicate that process with part B into the inequality and so on and so forth with checkpoint 3. So I'll leave those for you since it's very similar to algebraic methodologies. And let's get into something that will appear slightly more new. Okay, so one of the key differences between equations and inequalities is that an equation has one solution, right? So we might have x equals 4. 4 is that number that will satisfy this particular equation and make it true. Now, with an inequality, as we saw with, with checkpoint 1, right? All real numbers x less than or equal to -7. So what numbers are less than or equal to -7? Well, Negative 8 is less than negative 7. And negative 9 is less than negative 7. And negative 10. And negative 11. So on and so forth, right? So in essence, okay, for the time being, we can have an infinite number of solutions, okay? But we can also have an infinite number of wrong answers as well, right? So had I said 0, well, 0 is definitely not less than negative 7. It's greater. So we want to make sure that we shade in the proper direction. And if you notice, right, we have a closed red circle and an open red circle, okay? And they mean two different things, okay? So if we take a look at this first inequality, x is less than 1, okay? When there is no little tick mark underneath the inequality symbol indicating that it is or equal to, we want to use an open circle, okay? And we want all of the values that are less than 1, okay? So I like to think through this. Use your intuition. What values are less than 1? 0 is less than 1, and negative 1 is less than 1, negative 2, so on and so forth. So in this instance, we would want to use, we'd want to shade to the left. Now make sure you're looking and watching. Do not be the person that assumes less than left, okay? Because if I switch that inequality and I wrote it as 1 is greater than x, you would still shade it to the left because it's written backwards, okay? I'm not going to get into that at this stage in the game, but just be mindful, okay? Don't make, don't try to mechanize this. That's when mistakes start to happen, okay? We have another instance, right, where we have the arrow facing all of the values that are less than negative 2. So we want x is less than negative 2, but we have a closed circle, meaning that the negative 2 is allowed to be part of the solution set. So we simply just add in the or equal to, and our inequality is complete. Okay. Same thought process here with our next one. X is, but the inequality symbol is switched, right? Now we have greater than or equal to. So we want to make sure that we draw in a closed dot, and we want all the values that are greater than or equal to 0. There we are. Nice and straightforward. And similar thought process for the final one. The arrow is extending towards the values that are larger than negative 3, right? It's in the positive direction, but it is an open circle. So we want all the values of x that are only greater than negative 3, okay? None that are precisely equal. And that will do it for this. And I'll see you in part 2.